Hello, it's all about the parametrics today. We all know about the Cartesian equations where y is given in terms of x. We've known about them for a long time. But what are parametric equations? Well, parametric equations are equations where y and x are given in terms of a third parameter, usually t or theta when trigonometric. In this video, we shall look at how to differentiate and integrate parametric equations. We start with parametric differentiation. For dy by dx, we set up a chain rule. dy by dx equals dy by dt times dt by dx. Essentially, this is the same as dividing dy by dt by dx by dt. Please note that for stationary points, dy by dx equals 0, we can just put dy by dt equal to 0. Next up, we have parametric integration, for which we need to evaluate the integral of y dx. Just like integration by substitution, we need to substitute for y and dx, so we replace the y with its expression in terms of t, and in order to substitute for dx, we find dx by dt and make dx the subject. Note that if we are leaving the answer in terms of t, we also need to change the limits of integration. Two handcrafted examples for us today. Example 1. A curve is defined parametrically as x equals 3t times t minus 3 and y equals t cubed minus t squared plus 5t minus 11. Find the equation of the tangent at the point where x equals 12, t is greater than 0, and find also the other point on the curve where this tangent intersects the curve. 6-step process. Step 1. Find the value of t when x is 12. So we put 3t times t minus 3 equals 12 and solve the quadratic equation. We get two answers as you'd expect, but the question tells us only to consider the positive value for t, which is 4. Step 2. Find the value of y when t is 4. That's just substituting into y, which comes out at 57. Step 3. Differentiate parametrically to find the value of dy by dx. That's just the same as dy by dt divided by dx by dt, and once we've substituted t equals 4, we get a gradient of 3. Step 4. Find the equation of the tangent. Use the standard linear equation with x equals 12, y equals 57 and m equals 3, and we get y equals 3x plus 21. That's the first part of the question solved. Now the next part. Step 5. Substitute x and y in terms of t into the tangent equation. I've done that, as you can see. We get a cubic equation, but we already know two of the answers, because t equals 4 is the location of a tangent, so t equals 4 twice. The other value of t, as we can see, is 2. Finish off with step 6. Find the value of x and y, in which we just substitute t equals 2 into our parametric definitions of x and y to get minus 6, 3. Example 2 has a bit of trigonometry in it. For the curve y equals 6 sine 2t and x equals 2 cos t, A. Find the area bounded by the curve, and B. Find the stationary points. Step 1. Draw a sketch. Done that using a computer. From the sketch we can see that the total area is 4 times as large as the area in the first quadrant from x equals 0 to 2. We'll need to convert our limits too, so when x equals 0, t equals pi over 2, and when x is 2, t is 0. Step 2. Find a substitution for dx, i.e. find dx by dt and make dx the subject. That's minus 2 sine t dt. Step 3. Integrate between the limits. So we replace the y with 6 sine 2t, and we've already considered dx and the limits. We get minus 12 outside, and then sine 2t sine t, which we can rewrite using the double angle formula for sine, which is 2 sine t cos t. We can also swap the limits round to get rid of the minus sign. Multiplying our two sine t terms, we'll need to use integration by substitution. Sine t is raised to the power, so u equals sine t, whence cos t dt equals du. When t is 0, so is u, and when t is pi over 2, u is 1. This leaves us with the trivial integral of u squared between 0 and 1. Finishing it off and timesing by 24, we get a final answer of 8 for the bit of the diagram we've been looking at. Multiplied by 4, and we're done for the area. Part B and step 4. Find dy by dt using the chain rule. That's just dy by dt equals 12 cos 2t. Step 5. Put dy by dt equals 0 and solve. So 12 cos 2t is 0, and therefore cos 2t itself equals 0. The inverse cos of 0 is pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and when we halve we get t as pi over 4, 3 pi over 4, 5 pi over 4 and 7 pi over 4. Step 6. Substitute each value of t to find x and y, and we get 4 answers, as hopefully you'd expect from the sketch. So when t is pi over 4, we get root 2, 6, and then we also get minus root 2, minus 6, minus root 2, positive 6, and root 2, minus 6. Thank you very much for watching.
You want a my kind.